Welcome, everyone. My name is Ursula Weinhoven from the ITU New York Liaison Office. And on behalf of my colleague Johanna Joachim from the UN Innovation Network and myself, I'm really pleased to welcome you to today's session of TechLearnTalk. Today's theme is an introduction to robotics. We're joined by colleagues from UNICRI and UNMAS, whom we will introduce shortly. Before we start, we wanted to share a bit of context about this webinar series. Some of you may have joined before, but for those who have not, this webinar series seeks to help colleagues from across the UN understand new and emerging technologies and innovation a bit better. As we all know, the world is changing rapidly, and during the pandemic, the pace of digital transformation has further increased. And so it has become even more important for us to boost our own digital literacy and capacity. Before we give a bit more of an introduction, in preparing for this webinar, we came across a really cute, very short video that gives a different perspective on robotics than we're actually going to hear today in the webinar. So we thought we'd, technology willing, play it for you. Johanna, maybe you could just let me know if we can actually see it on your screen right now.
Sure, I can see it. Go ahead.
Lovely, okay, let us see.
What is an overpass? Come on. Question, is that an S or a 5?
I think it's a 5.
I thought so. Frustration loading.
For Rob Ott or Rob Ott.
Error human.
As you can see, it's pretty short, but it's somewhat amusing. So we hope you enjoyed that. And now we're going to return to our presentation, and we're going to give you just a little bit more background before we introduce our fantastic speakers for today. So one of the biggest advocates in the UN for innovation, digital technologies, and leveraging ICTs for the SDGs and for capacity building has been the UN Secretary General himself. And he's repeatedly stressed that innovation is a priority for him. And he has spearheaded initiatives, developed strategies and policy guidance, some of which is captured here in this slide. There is, for example, his strategy on new technologies, the report from his digital financing task force, his roadmap for digital cooperation, guide to blockchain, and his UN data strategy for everyone, everywhere. And he's also been a champion of the UN Innovation Network's Innovation Toolkit. Now there is, of course, his report, Our Common Agenda, which has digital dimensions. The UN Secretary General has expressed his expectation that everyone in the UN system will take steps to boost their own digital skills so that we can serve the world better and help the UN system to achieve its mandates. We're urged to think creatively, leverage technology and data sources in the work that we do every day. And here are some of the ones we were just mentioning. So as a contribution towards this goal, this TechLearnTalk series seeks to raise awareness about new and emerging technologies and how they're being used in the UN in a way that is jargon-free and doesn't assume prior knowledge about the technology concerned. We seek to create a safe and comfortable space for learning and to raise interest in learning more. Previous sessions of this series have looked at blockchain, AI, chatbots, drones, AR, VR, robotic process automation, predictive analytics, and other technologies. And today, we're super excited to look at robotics in a simple way that avoids jargon with direct examples of how the UN is already using robotics to advance its work. The recording and slides from today's session will be posted on the UN Innovation Network website in the webinar library, along with the previous recordings and slides. And we wanted to ask you a quick question just to check your familiarity with robotics. So Johanna, if we could put up the poll, please vote and we shall have the results shortly.
So I'm always very curious to see what the background knowledge for these kinds of conversation is. I have to admit,
Absolutely.
For this one, I know nothing at all. I've seen a few images, but I'm very basic. So very curious to see what colleagues on the call are saying. And I am I'm very pleased that I am not the only one who knows nothing, because there's 20% of people who are with me in that camp. But about half the people on the call have some background knowledge, and we have one expert. I wonder if it's one of our presenters. If not, so one expert. Majority are probably in the
probably all of our presenters.
A little bit camp, but not knowing too much. Back to you.
Fantastic. And then we have another little poll about what robots people might have in their house, or if people do have robots in their house, I believe. I remember reading somewhere, I don't know if it's still the case, but the most common robots, I believe, at some point anyway, were robot vacuums. So
yes,
with that reminder, maybe some folks have more robots than they thought.
A few people thinking about it.
Half and half, kind of, it looks.
Yes.
Not that I'm aware of.
Not that I'm aware of. Maybe there's a creepy robot sneaking in somewhere. Right, so half the people have, half do not. All right.
Fantastic.
Back to you, Ursula.
Thank you so much. So just a little reminder about how this goes. Let's just remove the poll. Thank you. Okay, great. Okay, so just to ask a question, please do use the Q&A function rather than the chat for your questions. That's because there's the opportunity as well to vote on questions that have been already posted into the Q&A. So that really helps us in the Q&A parts of this session. If you have experience though, or links on robots that you want to share, robotics that you want to share, you can paste that in the chat, but we will be focusing on the Q&A in this session. And the format will be, we'll have the introduction first, and there'll be a Q&A on that, then there'll be an example, and then there'll be the Q&A on that. So without further ado, I'm going to hand the floor back actually to Johanna, who's going to be our moderator in the session today. Johanna, do you want to introduce our wonderful speakers?
I love these glitches, Ursula. No, I would like you to do that, please, because I don't have my notes on that ready.
Sure. Apologies, everyone.
I'm very happy to come back later for Q&A.
Okay, fine, great. So in that case then, I'm pleased to introduce Irakli Beridze, head of the Center for AI and Robotics at UNICRI. And then after his early remarks, he will hand over to his colleague, Bruno Martins, who's a researcher at the same Center for AI and Robotics. So without further ado, Irakli, I'm going to stop sharing my screen, and I believe you're going to share your screen so that folks will be able to follow along with the PowerPoint.
Right. Ursula, thank you so much for giving me the floor and for giving UNICRI this opportunity to be part of this TechLearn Links of the United Nations run by UN Innovation Network and ITU. And from the onset, I would like to thank you personally and thank Johanna for this wonderful undertaking, which you've been running for quite a long time and bringing knowledge, expertise, and inspiration to all UN colleagues and beyond, to learn more about the type of work, what we are doing in terms of innovation within the United Nations and how this is going to benefit us, how it's benefiting different offices. So once again, thanks a lot. And on behalf of UNICRI and its Center for AI and Robotics, I would like to welcome all the participants and attendees to this today's event, where we'll be talking about robotics. I'm really excited about the topic. I'm very happy to see during the polls that there are colleagues who have robots, who don't have it, who have expertise, and some of them are real experts in this regard as well. Robotics is a huge topic, big topic, where UN member states have been investing from the private sector or from the government side as well. Governments are adopting strategies. Some of them are digital strategies, which also includes robotics on the sort of mechanic side. And from the private sector, robotics has become a multi-billion euro-dollar business globally, and it's been growing exponentially as well. And by 2025 or 2030, we have projects that together with the AI field, it can actually reach trillions of dollars in market share, which is an enormous which is an enormous undertaking on its own and will bring a lot of results and hopefully positive ones. That's why we do what we are doing at the United Nations at the Center for AI and Robotics of UNICRI, which is probably one of the earlier UN initiatives. When we started our work back in 2014, as a coincidence, robotics was our first focus, and we thought that we would be doing a lot of work on this, which we've done, but we also focused a lot more now on artificial intelligence, which goes hand in hand with this technology and gives a brain to the body of a robot to very simplify this topic. And we will be talking a lot more on this later on. Center for AI and Robotics of UNICRI, as I said, one of the earlier UN initiatives back from 2014-15. We started to focus on the mandate of UNICRI, how AI and robotics can be used in terms of in the field of crime prevention, criminal justice, rule of law, and human rights. Right now, we are undertaking numerous projects in that regard, how artificial intelligence and related technologies like robotics, blockchain, and other technologies can be used for benefit or misused for the malicious purposes by criminals or terrorists, or could be used by law enforcement agencies to solve crime-related problems. We are running, as I said, numerous projects in that regard. You can actually see all of it on our websites or follow us on the social media. Now, with this, I'm going to actually hand the floor to my colleague, Bruno Martins, who is going to give us a basics and advanced understanding on the robotics, and it's going to follow with presentations as well. Bruno is a researcher at the Center for AI and Robotics of UNICRI and has done a fantastic work in our team. Bruno, floor is yours. Please take it from here.
Thanks, Irakli, for introducing me. Let me share my slides. Are you able to see this?
Yes.
Yes.
Perfect. Well, thanks, Irakli, and great things that you mentioned also about the combination of artificial intelligence and robotics. That's, of course, super interesting. But I'm here today to give you a quick introduction to robotics, and I will do this using 4 topics we're going to discuss. First of all, I will treat what a robot actually is, what makes a robot a robot. Then I will dive into how robots actually work with a practical example, so no technical skills required. And afterwards, I will dive into what role robots can play in our future society. And having a bit of a vision about what robots will mean for us, I will also introduce some future trends that I think that will emerge over the coming years. And it's nice to already have been in touch with. So without further ado, let's start with the question, what actually is a robot? So what do we mean by robotics? Well, a robot is basically a machine that carries out a series of complex actions automatically. So it has the ability to think itself, and based on that come up with certain actions it should perform to reach a goal. And what's actually pretty unique about robots is that they are just like humans, present in every domain we are capable of being in. So they are in the water, and those are called ROVs, or remotely operating vehicles. And underwater drones, or what they often refer to, are mostly used for rescue operations or either for research, specifically in marine wildlife. And then we have robots on land. They are in a wide variety of sizes and forms. We have industrial robots, so robot arms, but we also have autonomous cars and a variety of healthcare robots, or robots that resemble human beings by their form and shape and also their behavior. Then we have robots in the air, drones or UAVs, and they are mostly used to map the environment or do observations for research purposes. And finally, and this is what I found pretty unique about robotics, is that they are also already widely used in space. So in the International Space Station, we have several robot arms that perform most of the outer measurements and adjust the sensors in the right directions. And we also have planetary rovers. So for example, NASA deployed some Mars rovers on Mars. So that's what I think is pretty unique about robotics. It's the only thing, just like humans, that is present in every domain. And that's not the only comparison I would like to make with humans, because Sometimes they also have a human-like appearance, but what reminds us mostly of human beings is actually their behavior. Because what's unique about robotics is how they work, and that's much the same as humans. So just as humans, they perform in a see, think, act cycle. And what do I mean by this? So how does a robot work? It works by a see, think, act cycle. And this slide might seem overwhelming, but don't get confused because I will get into every single point of this. But this slide is also the most important slide I have. So if you take anything away from this presentation, let it be this slide, because by this slide, you can literally explain every single robot there is. So what specifically is the see, think, act cycle? Well, just like humans, a robot has to have a certain goal before it comes into action. And for this, to reach this goal, they have to interact with the real world and come up with a plan of actions in order to reach that certain goal. And they do this using a see, think, act cycle. And let me go into every single of these points. Oh, I'm sorry. Yeah, so we start by the see phase, which is also often referred to as the see or the perception phase. So in this phase, the robot has to sense its environment. And for this, it often uses sensors. Just as humans have senses like eyes and ears, a robot has sensors, for example, cameras or infrared sensors. And using these sensors, it's doing measurements to observe what's around him. And using these measurements, it tries to extract certain information from the measurements. And that could be, there is an obstacle 5 meters away from me, but also things like there are moving things around me, but where am I located? And using that information that it extracts, it then passes that on to the think section. And in the think section, it can use that information to localize itself. So it creates a map of the environment. Where am I located? Where is my goal located? And what's in between there? Are there any obstacles? And using that map, it can then generate a trajectory or do motion planning to come up with a path it has to execute to go from a start state to the end state. And having obtained that path, it can start executing that path in the motion control phase. So how does that work? Well, in the motion control phase, the robot starts executing the path. So it actually, the actuators start moving, the robot starts driving or flying. But there's still one more step to be taken, because we of course have dynamic environments. So one could, for example, have pedestrians walking by, and this could result in the robot need to adjust their path. And that's what we do in the acting phase. So the robot remains perceiving its environment and then acts upon the changes in the environment in order to reach its goal state. So having introduced this see, think, act cycle to you, let me try to explain it to you in another way using an autonomous car, which is also a robot. And I'm using this because we have all been in a car and we can just very much relate to the decisions we need to make when driving a car, just as the robot or the autonomous car has to do. So for an autonomous car, it also starts with the see, or the perception phase. So a robot has different sensors, whereas human, we have different senses. So it has a radar, a lidar, and vision. And using these sensors, it starts measuring its surroundings. And having measured these surroundings, it can then extract certain information. So we foresee, for example, drawn blue boxes around the pedestrians here. So the robot has done measurements, and based on the 3 sensors, we can, with a certain probability, say that there is a pedestrian at a certain location. And it can then use that information to localize the environment. So to see where it is located and where its goal state is located and all the things that are in between, so its environment. And one thing I would like to specifically mention here is the concept of sensor fusion, because that's what makes robots really safe, just like humans. We have different senses when we are driving a car, and we close our eyes, we can still hear people or cars approaching. And this helps us to observe the environment in different ways. And this also holds for a car. So as you see in this picture, we have 3 different sensors. Well, the vision is the most important one, we all know that. But when we have heavy fog, we cannot see anything. And that's when radar and lidar still provide us with good measurements, because they are not affected by the fog. So sensor fusion, just as in humans, is very important for redundancy of a robot, because it can still perceive its environment may one of these sensors not work very well. Then moving on to the motion planning phase, the most easy way to describe this is actually the kind of the Google Maps of a car. So it has a certain start position, a certain goal where it needs to go, and all that's in between there will be planned by the motion planning algorithm. And it also uses the current conditions that are out there on the road, such as traffic, jams, and it tries to avoid that. So it generates many paths and then makes them all collision free, so it's not colliding with any buildings or with any other cars located on the road. And this will just come up with the most computationally efficient path to go in. And this is the path that is the most easy for the car to follow and will provide the optimal results. And this is actually a fairly complicated step for most robots, which requires the most computation power. And this is where artificial intelligence has shown very promising results, driving the innovation of robots and specifically of self-driving cars forward a lot. And then, having obtained the trajectory that we want to follow, the car can go into the motion control phase, where it actually starts driving. So it starts braking, applying gas, and switching lanes when needed. But what's very hard about this step is you can see, like in the picture, the person driving the car is reading, so it's not actually driving because it's an autonomous car. But the car still has to handle the environment on the spot. So it measures things, but these environments are dynamic, so they change. So you have pedestrians crossing the road, and that is where the car has to adjust for. And this requires really fast perception, and then motion planning and motion control again. So even within this big see, think, act cycle, you have several small see, think, act cycles, which are iteratively applied throughout the process. So this is basically how every robot works. So it perceives its environment, it comes up with a plan to execute it, then starts executing it while it takes into account changes in the environment or in the goal it has to reach. So now we know how robots work. Let me dive into what kind of role robots can play in our society. Well, as it is expected that robots will be very profound in our lives in the future. But why is that actually? Well, there are three major benefits that robots will provide us with. First of all, they will account for automation of skill-based tasks. So what do I mean by that? Well, all the simple tasks or tasks that we don't really actively think about anymore. So for example, chopping vegetables or driving a car, cars or activities that kind of became a habit, they could be automated easily using robotics. So we will see an automation of a lot of tasks we do on a day, providing us with much more time at hand. Secondly, it will enable humanity with new capabilities. We will have robots that cooperate with us and provide us with new capabilities. And therefore, we can have, for example, execute tasks with much more precision or in a safe manner, but also think about kind of exoskelets, which is an external robot that you apply to your body, enabling you to do things that you never could do before. So there are a wide range of activities that will become possible that we have never thought of, because we were simply not able to achieve that. And these two first points will also shift or work to more cognitive tasks. So you often hear that robots will take away our jobs. I really don't think this is the case, because even only the robotics industry alone will provide more jobs to people than it will take away. But apart from that, we will kindly shift our job spectrum to the more cognitive tasks. So we will have more time in a day at hand because we don't spend them on certain automated tasks anymore. And this will make people more developed and innovative and more intelligent over time. So we will continuously push our innovation forward. So when there are so much benefits about robotics, why are they not prevalent in our society yet? Well, there are basically three major challenges that we have to overcome before we could live a safe and happy life with robotics. So the first is that it's very hard to have robots interact with humans in a human environment. So most of the world is human owned, so there are only humans living there, or they are the strongest counterpart. So for robots, it's very hard to interact with that. And why is that exactly? Well, first of all, because robots have to deal with very unpredictable behavior, because humans are very unpredictable in what they are doing and how they are acting. So for a robot to not crash into a human, it needs to be able to see, think, act, and perceive what a human is doing very, very quickly. So that requires very good computational power and also good movement of the robots, so very agile robots. Secondly, we need to have robots that are cooperating with humans. Right now, when you go to an industrial setting, you often see robots behind fences, so people cannot get any access to them. And that's for a reason, because robots right now are programmed to pursue their goal. So when you get in their way and try to apply resistance, they will just apply all their force to break through you and to get to their point. Well, currently they are developing so-called torque-controlled robots who can measure the force you or the resistance you apply to them, and then know, okay, this is a human that's in the way, I need to back off. And we need this technology in order to have robots around us. And finally, what's very difficult about engineering robots is that research shows that when we apply robots in a field, that humans will adapt to the robots. So we don't really know how humans adapt to the robots yet. But we need to iterate on the first robots because people will behave differently around them. And this will bring new challenges. So for example, when you have a self-driving car, am I still there?
Yeah, very much still here.
Okay. I thought I lagged for a second. So, but for example, when you have an autonomous car and people are used to it, they are just crossing the road in trust of the autonomous car, which can give very different situations than right now, where they are looking actually if a person is stopping for that. So a second big challenge is that of ethical considerations, and that's a whole research field on their own. So I'm not going into that, but for example, look at the background of this slide. Do we want robots that resemble human beings? Because that has a lot of ethical obligations with it. And then we probably also need to think about, are we going to treat robots the same as how we're treating humans? So there's a whole need for a big policy making industry for robots specifically, and that's not where we're currently ready for yet. So this is also where the UNICRI Center for AI and Robotics is thinking about how can we safely integrate humans in our daily life. And the last challenge to overcome, and that's one I think that's the easiest to overcome, is that of cost. Because to give you an indication, when you have a currently state-of-the-art robot, let's say a specific cyber dog, so it's yellow, probably you all know which one it is, that costs around $100,000 to $200,000 right now. So that's still very expensive. And what's driving up these costs so much are these sensors. So I earlier talked about the torque-controlled sensors to measure the force of humans. They are very expensive right now. So we have LiDARs on cars, which are very expensive. But there has been a lot of progress in terms of the sensor technology, driving them to much cheaper production prices. And this will also, I think, at least halve the price of the robots as they are right now, which will make them much more accessible for human beings. So now we know what robots can mean to our society. Let's take a look at some future trends that will emerge in the coming years. First of all, this one is of the coolest ones, I think, is that of robotic swarms. So what do I mean by that? It's basically a team of robots that tries to pursue a certain goal. So let's take a rescue mission in a cave as an example, where someone is tied up because of some stones collapsing very deep in a cave. Then we could use a cyber dog that goes into the cave, but it cannot really go behind the stones that are blocking the person from going out. But we can equip that dog with a certain small UAV or a drone that can bring medicines or even food and drinks to that person for the last small part. So it has a very limited range because it's a small drone, but then it just does that part and is taken back by the robot dog again. So they can collaborate to execute a certain mission or goal. And this will provide us with many capabilities, even in other fields. But what's hard about robotic swarms is that it requires adapted hardware, because the robots need to be able to communicate with each other and communicate its state and ways to act on that. And also it's very difficult to let them work together for that same reason, specifically in a human-owned environment. Because I told you about that robots need to account for humans and adjust their behavior based on them. That also holds for other robots that need to make sure that they don't collide, for example. Another trend is that of bio-inspired robotics. So what do I mean by that? Well, it's basically engineers who use elements from the autonomy of humans or animals in order to come up with robots that are much more human-like. And it's actually very logical to go by this way because evolutionary has shown that it's the most effective way to do a certain task. So by making robots follow these evolutionary principles, they can become much more like humans or even animals. You have some gecko robots that are able to climb up walls nowadays. And a lot of research is being put into this aspect, and very promising results are even achieved already in the laboratoriums. So expect to see this in the future. And then the most important one, in my opinion, is that of reinforcement learning. And that's basically an artificial intelligence-based technique that is making robots learn pretty much the same way as humans or animals are doing. So it's making a robot learning by doing. So what do I mean by that? Well, take a look at the Rubik's Cube you see in the background. The engineer do not longer need to know how to solve a Rubik's Cube itself, because earlier on it had to program every single step to do it. But now it can just say, okay, I want to solve Rubik's Cube. So it shows the robot a Rubik's Cube that it's solved. And then the robot starts randomly trying operations, which then get punished or rewarded. And based on that, the robot learns what the right way to go is. And over time, it will then be able to learn much more quickly than a human how to solve a Rubik's Cube. And this is specifically a challenge that will, or a trend that will overcome many of the challenges engineers currently face developing robotics, and will revolutionize robotics in a very positive manner. So I hope to have given you a good introduction to robotics, and thank you for listening. If there are any questions, please raise your hand.
Absolutely, there are questions for you, but first of all, thank you, Bruno. Fantastic introduction. I am very grateful that you have managed to introduce such a complicated topic without going too much into technical language. I feel like I've learned a lot. I'm not going to lie. I was the one who said that I don't know anything about robotics at the start, so I feel educated and quite inspired. And when you were talking about robots, I had to think back to an ITU meeting, actually back in Geneva when the world was still in person, where I met Sophia, the robot, and she was very human-like. It was almost spooky. It was very impressive, but almost spooky. And that then got me thinking to maybe some reading inspiration for colleagues who are interested. There's a new book by Kazuo Ishiguro, the Nobel Prize winner, and he wrote a book called Clara and the Sun about the relationship between humans and robots going forward. Also a little bit spooky, but kind of interesting, and it sounds very much like we're going in that direction. So thank you for that, Bruno. I have a bunch of questions for you, so let me come to them. And I always like to start a little bit easy because you've just been working hard giving us this introduction. So can you maybe tell us if robotics originated from space research like the internet did? You said they are actually in space, they're on land, on air, underwater, on space. Is that actually where robotics come from, or is there a different origin story?
Partially, because robots are often handy, or they come in place when people can no longer access certain parts, which is often the case in space, of course. So yeah, there definitely are some origins in space, but people have been thinking about robotics already earlier on. And to be fair, I think it actually originated in an industrial setting where they wanted to make machines capable of doing more, and then came up with the first robot.
Great, and that could be settings like, I'm guessing, airports where you have people lifting suitcases, or different kinds of settings?
Yeah, for example, but also more like producing certain goods, products, cars.
Oh, of course, in the car industry. Great. You see, I have a very steep learning curve here. Thank you for bearing with me. And talking about learning curves, the next question in our Q&A box is, what is the learning curve for robots? As in, how quickly are they getting better? And when will they be sitting in coffee shops like the Robot robot that we saw at the very beginning? What's your prediction?
Yeah, that's of course a very good question. And I think this kind of goes hand in hand with artificial intelligence as well. And nowadays you see very promising videos online of, for example, Boston Dynamics. You see robots dancing, doing very complicated tricks, or free running parkour kind of videos. And I would like to give a more realistic expectation to it, because these are performed not in a human environment, so they are pre-programmed. They know every dynamic move to make, and they are very optimized to that certain movement. So right now, there's not a chance that you will see a robot doing that next to you on a field, to say so. So, but I think, like what I also said, the reinforcement learning will help us a lot in not have to program every dynamic and every movement and calculate every single piece of a robot or its actions. So that will drive the introduction of robots much. And I think in 10, 15 years, you will have like robots fully taking over certain jobs. Yeah.
So Clara and the sun is about 15 years away. Exciting, I guess. Sorry, I'm giving myself lots of nice cues here. I also have two questions. In your center's book, do you find that more people are excited by robotics or fearful of it? What are your thoughts on that?
Both. You need both, I think. Like there are, of course, people that see the potentials of it. But I think it's also nature of and also a responsibility of the UN to be a bit critical about the development. So I think most people are super interested in what's happening and see the potential of it, but they're also raising critical questions, which I kind of left out of my presentation, but going more into the ethical considerations. I really, for example, think that we should not have robots that look like humans, because it will conflict very much with human rights, and there are even people saying that we should give rights to robots, and yeah, it's a pretty complicated way to interact with, because I think robots are our digital counterparts. So like they are in every domain, they work much the same as we do, and they will get the same capabilities powered by artificial intelligence as we do, or even more. So that's something you should handle in a considerable manner. So in the UN, people are very much aware of that, and I think they find the balance between that good. Yeah.
Okay, that sounds encouraging. I'm going to throw two more questions at you, and then we're going to go into a case study, and then we'll show you how the UN is already using robotics. And Bruno, I'd like to ask, you said the UN is in a good place to try and help safeguard some of these risks. What are we actually doing to prevent the worst case scenario? One of our colleagues is wondering. So what steps should or are being taken so worst case scenarios of robots taking over don't come to pass?
Yeah, I think to raise this a bit more to artificial intelligence, because it's already a bit further developed, so a bit more of a realistic risk in the short-term future. But then you see that there's a lot of advocacy building done, so people are making, or the UN is making people aware what it actually is, how it works, and what it will mean for us. And by doing that, I think people better understand and are better able to interact with it. And secondly, you also have policy-making groups, and those will help to use these technologies in a very responsible manner, which we eventually need, of course.
Absolutely. And I think that's a good opportunity to give a shout out to our colleagues at UNESCO who are working on, I think, ethical principles for the application of AI. So I'm guessing those are also very closely linked to the work that you're doing here. Bruno, last question for you, and then we'll give you a break. If one wants to learn more about robotics, where can we go? What resources are there? Has the center developed some? Are there some courses that you could recommend?
That's a good one. I think like robots is, you can learn robotics pretty much by looking at how they move and how they are doing themselves. So I didn't include any videos, and that's actually a bit pity, but I would recommend you to go on YouTube and just watch a few videos to get a better idea of what the current state of the art is. And then I think there are some pretty good online courses on I think Coursera and websites like that, and most of them are even free. So that's a good way to get a bit into it.
Great. We like good resources and we like them free. So maybe, Bruno, if you have 5 minutes after this, maybe you could put together your favorite ones or the best videos that you've seen, and we can include them as the share out, so that people have a recommended resource that they can follow up on.
Yeah, sure. I will do that.
Fantastic. So thank you so much for the non-technical introduction. We'll see you again in a little bit, but right now we're going to our second presenter for the day, Akriti, welcoming you to Common Video. Hello.
Hi.
Good to see you. I'm glad you could make it. We have a few issues with your presentation, so we'll be sharing the screen on your behalf. But everyone, we're very happy that Akriti is joining us. She's a deputy project manager working for the UN Mine Action Service in Somalia. And Akriti is working on actually applying robotics in the world of the UN. So a real life case study. So really happy that you're here today, and handing over to you for your presentation. And thank you, Ursula, for advancing the slides.
Yeah. Thank you, and thank you very much for helping me with sharing the slide. I had some issues sharing it from my end. Welcome everyone. So basically, I will be talking about the remotely operated vehicles that are being used in improvised explosive device disposal in UNMAS, Somalia. So when we're talking about the threat in Somalia, or the context that we're working in Somalia, the IEDs, which are the improvised explosive devices, are the threat that we encounter here in Somalia. Just in 2021, we had 462 IED incidents, and most of the IED incidents actually occur in the main supply routes. What I mean by that is routes that are used for the movement of logistics to the places where the troops are stationed and for the operations. And then the routes, they have the high traffic flow compared to the other routes. So the reason I'm mentioning all this is the remotely operated vehicles are actually used in this context and are deployed in these main supply routes, the roads where the IEDs are encountered most, and in urban areas where we encounter the IED the most. So basically, I'll be showing you some animation to actually show what I mean by encountering IEDs on the road. Next one, please.
So here we should be seeing a little animation, right? Let's see if we can get it up for you, Akriti. There we go.
Oh, should have been a click. Oops.
Apologies, I'll be better next time. I wasn't coordinated enough.
No worries. Basically, this animation was about like a vehicle going or passing in the road and encountering IED, and then an explosion occurs. Basically, it depicts that. There we go. Thank you. This is for the military vehicle. And the third context is, a passerby passing in the road and encountering IED. So these incidences happen frequently in Somalia, and we have been using the remotely operated vehicles in these instances. So can we move on to the next slide, please? I'll focus more on the remotely operated vehicles that are used in Somalia at the moment. As we've already discussed, these are used in different kind of industry, and they're very sophisticated piece of equipment. They can be used in different contexts, different industries, including construction industry, humanitarian sector for relief distribution. And for us in the humanitarian mine action context, we're using it against the improvised explosive devices. And then the one that we're using here at the moment is called MK3 and MK4. And we will see, this in the video. If we move on to the video, please.
It seems to be having some challenges, and I don't have access to the video. I don't know, Johanna, if you have
it's a video on. Go to the next slide, please, Ursula.
Yes.
And there should be a link there. I love, by the way, that we're talking about robotics and we're failing to make Zoom work.
That's why there's this wonderful quote about how, you could say AI and robotics is easy, but AV is hard.
Absolutely. Yeah.
I guess there are some limitations, and then I think we encounter these frequently.
Let's try, I'm stopping the sharing.
Or whether it's using the ROV.
Okay, let's see. Screen share.
Okay, so if you, there's a slide that is a black slide and it has a white box on it. So if you click on that, I click on the link, then that should take you to YouTube.
Like, let's see. No.
Sounds funky. And now, Ursula, apologies that you're stuck with the screen issues, but we now need to switch to the screen that has the video, not the slide one, please.
Oh yeah, sure.
Okay, we're getting there, Akriti. Thank you for bearing with us. I am feverishly thinking about other robot reading inspiration that I could give to you to bridge the time. I cannot think of any. Everyone else has one.
Can you see it at the moment?
Unfortunately not, no.
Oh.
Seems to be hidden. Akriti, how shall we do this? Shall we include it in the send out and then colleagues can
Yes,
watch
I think
then?
that's a good idea. The music is lovely.
So maybe let's go to the next slide and maybe Akriti, you can tell us what was on the video. I know it's not as good, but while we're mastering the AV, may have to work for now.
Yeah. So basically, you know, it was how agile in a way the ROV can be, and then how it can be used in different contexts. For example, you know, they can move in a heap of sand or like a heap of rock, or, you know, it can access areas that are under the bushes, the areas that would not have been accessible to, you know, human being, or like or a car, or it might be a small narrow gap where we cannot access those areas. So basically it was a video of like how it moves around. So moving on to this one then, how does it work? So how does it work is I've only included the major input and outputs for you guys in this slide, and as you can see in the picture, that's how like the MK3 also looks like. It has a claw in the front, and then, you know, it looks pretty much like the tank to make it more agile, more movable, and it's very robust. It has tracks so that it can, you know, it can move around in, as I mentioned, areas where there are heaps of sands or rocks, or a normal road, you know, or a stair. Basically, it can move up the stairs as well, and then access different areas. So how does it work? Movement of robotic arms. So we use these robotic arms for different purposes. And one of the main reason we use the robotic arm is to actually open vehicles or access areas, pull out certain things from different locations. If we have information that, you know, and then if we have information that these devices are inside a vehicle, for example, then, you know, these claws are used to open the vehicle, look around. And these arms can actually stretch to certain lengths. So, and it has the camera fitted in it also. So it actually allows us to see what's inside the vehicle. Also, so that, you know, we can use the right kind of device, right kind of system to actually take care of the explosive device that is inside that vehicle. So movement of the base, it's to allow the movement in different direction. It can move forward and backwards. And the next one is the video feedback with the wireless camera. So it helps us look at the device that is, you know, basically being encountered. And we gather like more information about the location and surrounding by using these cameras. It actually has, or we actually, you know, install 3 cameras in this ROV, and then these different cameras have different functions. So, and then the input signal, I mentioned the joystick control, because the joystick can also be used in this robot so that the command can be given. Next slide, please. Yeah. So what is it used for? It is used for, as I mentioned, improvised explosive device disposal. and it allows, remote way to make sure that the IED doesn't hurt anyone. So basically we call it the render safe procedure. It is used for reconnaissance. What I mean by that, it allows us to see what kind of device is being used, and confirmation of ordnance or components. It's pretty much the same thing, but like the exact details of how it looks like, whether it is a small device or a big device or something very sophisticated. And then, as I mentioned before as well, it's gaining access to vehicles, various containers, bushes, areas that are not reachable otherwise. Next slide, please. I know there is a long list in here, but I think what I want to emphasize on here from this slide is it is mostly preferred because it allows us to access the device remotely. The operator actually kind of doesn't have to access the device himself, herself. It can be done remotely, which basically means, it is less time spent next to the improvised explosive device trying to disrupt or trying to destroy it. So it actually ensures the safety of the operator who is in charge of the situation, and it allows for the speedy attack on the device. What I mean by that is, in a small period of time, this device can be tackled, which otherwise would not have been possible if a human was to approach the device. And another major important thing is it allows us to actually remotely see what device are we encountering, what are the details. And then the last one being effective means to place disruptor and donor charge. I'll be explaining that in the next slide. So those are the most important reasons why we prefer to use this in the IEDD context. Next slide, please. Yeah, as you can see, this is a picture from one of the training. This is now MK3 being used to basically tackle the IED device. So the method of disposal, there are two kind of methods that we use. One is we use a disruptor, a charge, a weapon system on the robots on the MK3, and then we shoot. And then another one is using a charge next to the IED and destroying it. So for both purpose, these ROVs can be used. Next slide, please. Advantage. So the advantage of the ROV is basically it saves life, and it can be controlled remotely. So exposure to the improvised explosive device is very less and very limited when we use these robots. And this can be used both indoors and outdoors. It is very fast and robust, and it can carry different loads. So if we need to, move, let's say we have identified or we've been informed that there was an explosive device in an airplane, and we need to, basically move the device from the airplane storage area, then it can be used. Even inside an airplane to basically move different devices from there safely without, actually exposing the operator or without exposing other human beings around that space, and ensuring the security of everyone. So movable robotic arm, I've already given that example before. So it really allows us to reach areas where human beings would not have been able to reach otherwise. And the most important one is provides the video output to the operator. So it actually ensures that we have access to the video of the device itself that we are encountering, or the surrounding areas, to identify which are the possible kind of routes that we can use to access this device to kind of make it safe. Next slide, please. Disadvantage. As we've already mentioned, there are advantage and disadvantages of the remotely operated vehicles. Some of the disadvantages are the user, of course, has to be trained on the controls of the robots. So you would need someone who has done the training on the robots to be able to use it, because one has to be very precise while using these robots, and have to be very careful not to damage the circuit, because it's basically, uses the circuit and also the battery system to function. So you have to be very careful not to damage the circuit. It requires regular maintenance, and that means added cost. So regular maintenance is required. We actually have a special technical person here with us working on the maintenance of these robots. So that means, the cost is added to maintain these robots. So spare parts is the same. We are using this for operation very frequently, which means some of the parts get damaged and destroyed, and the spare parts has to be brought in again and again, which also means added cost to the operations. So, and then it also has few other limitations, which are there in the next slide. Next slide, please. As you can see, there are different weights mentioned. So basically, depending on the position of the arm, there is a weight limit. For example, the 20 kg, it's like when the arm is not extended, it can carry 20 kg. When the arm is extended, it can carry 8 kg. And then when the arms are on the side, when the turret rotates to a different direction, then the weight limit is 6 kg. And when we are talking about the incline, if the maximum incline that it can climb, let's say climbing a stairs, if it is very steep, then it might be a problem. So maximum 45 degrees, it can move maximum of 45 degrees when it moves up the stairs. And on the side, maximum of 35 degrees. And then it has a time limitation as well, because the battery will only last for 4 to 5 hours when it's new. And then the battery life kind of reduces. So the hours will become less and less, once the batteries are older. I think that's it from my end. Thank you very much.
Thank you, Akriti. That was great. I'm so happy to know that there's a part of the UN that is using robotics already. We have been planning this webinar for quite some time, and I set myself the challenge that it has to be a UN case study that we're showcasing. It can't just be an external startup. So congrats to you and your colleagues for really doing cutting edge work. I'm really, really happy that you could join us. I have some questions, and we have a little bit of time that I'd like to put to you, and then maybe one for everyone who spoke today. And Akriti, the question I like the most is what you touched upon it, but what were the biggest challenges that you were facing when introducing robotics? Was it, you mentioned skills, was it skills, was it cost, was there some regulations on the ground, maybe from the government side for their use? What was actually the hardest part? Could you reflect on that?
Yeah, I think the hardest part for us was the budget, was the cost, because these devices are not very cheap. It can cost anywhere from $150,000 to $350,000, and then there is that added maintenance cost. There is that added sort of spare part cost. So I think the biggest challenge for us was the cost factor. But over the time, we were able to kind of procure these devices in enough number to be able to support what we do here in Somalia. That's
great. Can you say how many you have at the moment?
We have around 21 here at the moment.
Oh, wow, okay, that's a lot. And then I have a not so fun, but kind of funnily phrased question. So first of all, the colleague is saying it's a great case study, thanks for sharing. And then they're wondering what's the success rate of using the robots to dispose of explosives. And I'm picturing this very, very graphically. The colleague is saying, do they sometimes fail and blow up? Has that happened before?
Yeah, I think we were very lucky. It hasn't happened in Somalia, but I think it depends on the complexity of the device that is being used, the explosive device that is being used, and I would not say that is not possible. That might be possible, blowing up the ROV itself, but for us it has not happened. And talking about the success rate, it depends on the operator's skill also, like how great skill does the operator possess. and based on that, the success rate is decided. So we have here with us in our project, we have mentors. So basically we have people who have worked in this field for nearly 10-15 years doing the same thing in different contexts. So these mentors sort of kind of mentor, the operators on the ground. So we're very lucky in that sense that these mentors are always with the operators on the ground. And that's why I think, with blowing up the explosive device, we sort of have like a 100% success rate.
That's fantastic. Thank you. And congrats to you and the colleagues
on the ground also. So sometimes, we might not be able to basically send them off in different locations because of many reasons also. So we also have to consider that though.
Great. No, that makes perfect sense. And Akriti, I'd like to give the last question for the day to you first, and then invite Bruno and Irakli maybe to come in and comment. And colleagues were wondering, what are some other areas where you think robots have the biggest potential for the work of the UN? So you're obviously using it for explosive devices. Can you think of something else where you've seen a use case and be like, that would be fantastic to use a robot for?
I think for me, I'm not quite sure, maybe I have limited knowledge on this, but I feel like it can be really used in humanitarian relief work, I believe. There are areas where these areas are not accessible because of security reasons, or like there is like a flood, which is why we're not able to access the area, or like, certain sort of other security concerns are there, which is why we're not able to access these areas. But the need for the food relief or like for the medical supplies might be really, intense in that area. So I believe like maybe this is, an area, humanitarian relief work maybe can benefit a lot from the use of robots and basically drones, if you understand what I mean. I think, for me, it's the humanitarian relief work. Yeah.
Great. Thank you. Bruno, do you want to add to that?
Yeah, I agree. I think it's mostly to all sustainable development goals it can contribute. But yeah, to name a few examples, for example, drones can be used to map environments and see whether there's drought in a certain place, or see how much water is still left, and that can be used to increase what comes out of the fields in very dry areas. There are some other applications as well. Dealing with disasters, that's where robots are. You see that often, like also with the use case of Akriti, that like they are being used where we as persons do not want to go. And that also holds when a disaster occurs. They can be helped to rescue people to go into caves, for example, the example I used in my presentation. So we often use them when we no longer think that we can do it ourselves.
And I think building on that, we have our colleague Ida from ITU. She's saying that robots are actually being used in Rwanda to help with COVID screening of patients, where they take the temperature, monitor sick patients, and maybe sick in detail. I believe that might be a UNDP project. Thank you, Ida, for sharing. So lots and lots of applications, maybe everywhere where humans don't really want to go. I like that. We have a ghost Irakli appearing. Irakli, if you want to add a quick case study, otherwise I think we're over time and we should be wrapping up now.
No, thank you so much, and it was a fascinating discussion, and I also enjoyed myself actually to be part of it. UNICRI is always happy to share its experiences, and to all the participants, would be happy to, if you have any questions or interests or suggestions or ideas how to do certain joint projects together, we'd always be happy to consider it, especially in the area of robotics and the digital transformation in general. As I said in my opening remarks, robotics is a huge industry which is going to become even bigger once we're going to enter the sort of a new dimensions of the technological transformations, and it will be driven with ideas like metaverses and numerous other initiatives which is happening all around us, which is going to transform the world, and hopefully it is going to transform the world for the better. We will solve enormous and big problems like UN Sustainable Development Goals, which we hopefully will make a lot of progress in, and many other things. I'm an optimist by nature, and I believe that technology will be used for good, and all these efforts which is done throughout the UN and other colleagues related to us is going to push that forward, which will bring a lot of benefits to everyone equally, to sort of also address the issues related to this widening the digital gap, which is happening globally, and we'll hopefully definitely need to do a lot more on that. With this, I hand back to you, Johanna, and thank you and Ursula in that regard to organize this fascinating discussions.
No, thanks to you. I very much echo your final words, Irakli. I'm always an eternal optimist, and I think there's a lot of reason and room here to be optimistic, especially because looking at the fantastic skills that we have in the UN already, no one can ever say that the UN is not using cutting-edge innovation in some of the hardest to reach places in the world. So congrats to you and Bruno. A fantastic work, Akriti. Thank you so much for joining us. Thanks to amazing co-host Ursula. Pleasure to do this webinar series with you. And we'll be looking for more interesting topics and bring them to you in due course. And with that, a big thank you from us and a very good day to all of you. See you next time. Bye-bye.